Hello and welcome back. Today we're going to be talking about functions. So we've talked about this a little bit, but I want to go ahead and go over another little bit on the board just as a refresher because it's been a little bit and maybe some people didn't necessarily go through those earlier lessons, so we're going to go through them here. So a function, f, is basically a number machine. So x can be any of these numbers over here. This is usually called the domain. We plug those into the function, and the function spits out, typically it's y values, but it can also be called the range. So I like to put this akin to something like gas in a car. So if your domain is gas, right? So if you have gas and your function is the car, then the range, the output, is going to be the miles that the car travels when you put the gas in it. So you put the gas in the car drives, and it puts you a certain number of miles away from where you started. So this is how I like to use the metaphor for what a function is. It turns numbers into other numbers, is the long and short of it. But now that we've got that clarified, let's go ahead and jump back, talk a little bit more about domain. So domain are the numbers that you can plug into a function. So the domain is like, as I said, if a function is a car, then the domain is the gas that you put in the car. Now, most functions, not all, but most functions allow you to put in whatever number you want, but some of them don't. So let's take a quick peek at a function that doesn't allow you to just plug in whatever number you want. So a function that would let you plug in whatever you want. So f of x equals 2 times x. So this is a function where you can plug in whatever you want and you get a number. You think of any number that you could possibly imagine, you plug it in, and it's just 2 times that number that gives you a number. So you can always get something out of this function no matter what. Meanwhile, let's say g of x. So functions can have different names. This one's name is f, this one's name is g. So g of x, let's say, is 1 over x. So now this function actually has a restricted domain. So it has a restricted domain. So restricted domain. There is at least one number I can't plug into this function. And if you're familiar with, division, you probably figured out that the number I'm not allowed to use is 0. So I can't plug 0 into this function, because if I tried to do that, if I tried to do g of 0, I would get 1 divided by 0, and oh no, I can't do that. That's that's an illegal algebra. You can't divide by 0. It's not possible. So that means I can't plug in 0 in the first place, which means that my domain would be every number except for 0. The domain is x cannot be 0. So there are some situations where, if you plug in a certain number, you won't get an answer. That means that that number is not a part of the domain. Any other times, you're perfectly fine to plug in whatever you want, but things like dividing by 0 or taking the square root of a negative number, those are going to be situations where your domain is restricted. But what you're going to find is that often you don't really have that many restrictions on your domain. So that is what domain is, and that is how we make it work. So range is a little bit different. So if a function is a car and the domain is the gas, then the range is anywhere the car can take you when it has the gas. So it's how far you can travel. So let's look at 2 instances of domain. And this is where graphs are really going to help us. So that function I did before, let's do it in a different color. Let's say I have f of x. So f of x is 2 times x. Okay, so that line is going to look like this. So with this particular graph, my domain is always restricted by its y values. So since this graph goes up forever and it goes down forever, my range is whatever number I can think of. Negative infinity to positive infinity, the whole kit and caboodle, every up and down value, I can get all of those wherever I want. But there are some functions with ranges that are a lot more limited. So let's say g of x is equal to x squared. So x squared would look something like this. So you might have noticed, so x squared goes up forever, but it doesn't go down forever, which means that the range of that function is going to be a lot more limited. So I can only go down until I hit 0. So the lowest y value I can hit is y equals 0, which is fair. If I plug 0 in, 0 times 0 is 0. But it may not be immediately clear why I only go up. So let's try -1 and see what happens when I plug in negative numbers. So if I plug in a negative number, so if the x is a negative number, so that would be right about here, then I would have -1 squared. So -1 times -1 is +1. Oh, so even if I plug in a negative number, I will always get a positive answer. So that means I can only go as low as 0, but I can keep going up to infinity. Because remember, the range is concerned with the y values. So if the x values are what I plug in, the y values are what I get out. So graphically, since I only go up, so since I start at 0 and I only go up, the range for g of x is going to be 0 to infinity. And this is what range is. It's what do I get out of this function after I start plugging stuff in? That is what range is supposed to be. So some examples of some domains, functions, and ranges, because again, these don't have to strictly be numbers. A function is just something that takes inputs and turns them into outputs. That works just fine. So for instance here, if we have bread, so I don't know why I mixed these up. I probably mixed these up so that we can go over them in the synchronous hours, but I'm going to explain them so they don't look so crazy. So bread is something that you put in a toaster, and when you put bread in a toaster, you get toast. So bread would be domain, toast would be the function, or I'm sorry, toaster would be the function because you put the bread into the toaster, and then the toast would be the range because that's what you get out of the whole ordeal. Going a bit further, so water, you can put water into a freezer to get ice cubes. So in that situation, water is the domain, freezer is the function, and ice cubes would be the range. In this case, so firewood, fire pit, and a campfire. So firewood is your domain because you put the firewood into the fire pit. And then once you put the firewood into the fire pit, you can make a campfire, so that would be the range. And then meat, grill, and then steak. So, you take meat and you put it into a grill, and then you get the steak. So domain, function, range, pretty straightforward. So now let's talk about the places where you can break domain. We've talked about this a little bit. But we're going to go over the 3 main places where there are just certain things you're not able to plug in. So the main rule to stick by is that if plugging in that number would give you divide by 0 or a answer that is not a real number, it's not going to be in your domain. So let's go to the board and we will do a couple of examples going over exactly that. So clean that up. There we go. Okay, well, there's a little bit there. Okay, so now let's say we have the function. So f of x is equal to 1 over x minus 2. Okay, so just like last time, we can't divide by 0. So x minus 2 cannot be 0. So the cannot sign works just like the is sign or the equal sign. This is does not equal. So x minus 2 is not 0. So this is the rule we got to follow. So we're going to do our algebra as though it were an equal sign, which means that we can add 2 to both sides. So x does not equal 2. So for our domain, x is any number as long as x is not 2. So if we were to write that in interval notation, that means any negative number is fine, but we can't use 2. And then also we would say 2 to positive infinity is how we do. By the way, this symbol is called the union symbol. It's also known as the OR symbol. So if you're doing interval notation and you're trying to specify 2 intervals, this is how you specify that you could have one or the other. Either one is fine. So in this case, negative infinity to positive 2, 2 to positive infinity. Every single number is listed here, except for negative 2. We're not allowed, or except for positive 2. We're not allowed to use positive 2 because 2 is the only number for this function that doesn't work. So with that in mind, let's now do another one. So let's say for this one, do g of x. So let's say g of x is equal to, say, the square root of 3 minus x. Okay, so when we're talking about square roots, so we can't take the square root of a negative number, right? So a negative number just means that it is greater than 0, but we can take the square root of 0. So it needs to be greater than or equal to 0. So in this case, if I were to take the square root of 0, that's fine because the square root of 0 is 0. So 0 is okay. That's why we have the underline there. But in this case, what's inside is the 3 minus x. So whenever you see a square root, that stuff has got to be bigger than or equal to 0 because, you know, if it's a negative number on the inside of the square root, that means we're taking the square root of a negative number, and that's not something we're doing right now. There are ways to take square roots of negative numbers, but when we do that, we don't get real numbers. We need real numbers in order to make this work. So right here, we're going to go ahead and do this little bit of algebra here. So we're going to say, we're going to add x to both sides because, again, you know, this is an inequality. We've done these before. So 3 is greater than or equal to x. Okay, so as long as x is 3 or smaller, we're good to go. So 3 works, and it works, so we get to have, you know, the bracket. But it's got to be smaller than 3 or 3. So negative infinity all the way up to positive 3, that works because, you know, 3 is the largest number that we can have, and any number smaller than that works. So whenever you're doing square roots, just take this guy on the inside, set it as greater than or equal to 0. You'll be good to go. Just do a little bit of algebra. You'll get your answer in no time. So that's the second situation where you're going to have to fix your domain. But beyond that, there's only one, and the good news is you already know how to do it for the most part. So let's say f of x is, let's say it's x minus 2 over the square root of x plus 3. Okay, so square root, so x plus 3 got to be greater than 0. But notice how there's no underline? I did that on purpose because if I plugged in, you know, if I got 0, I'd have x minus 2 over 0. Uh-oh, no, I can't do that. That would be divided by 0. So I can't have 0. That's why I purposefully did not say equals 2, because x plus 3 needs to be bigger than 0 in order for this to work. So, you know, we're going to work this the same way we did algebra before. And by the way, in case you were wondering how the x minus 2 changes how we do this, it doesn't. It doesn't matter whatsoever. We do not care about the top unless there's a square root on it. So we're just gonna ignore that because it doesn't matter. We're only worried about the bottom of the fraction, and we're only worried about the square root. So that's the stuff we're going to deal with. So moving forward with that. I probably shouldn't have scribbled it out so hard because, you know, it is part of the equation. It's just not the part we care about. So over here, we're doing the algebra. So minus 3 minus 3. So x needs to be bigger than negative 3. So negative 3 is the smallest number that x can be, except it can't be that number because, you know, negative 3 is not bigger than negative 3. So negative 3 is the smallest number that we care about, and we need to be anything bigger than that. So between negative 3 and infinity, that works. So this would be our domain for this function. So the only 3 places that domain can break, and hold on, let me clear the board. So the only 3 places that domain can break is if you have, you know, the square root of something, 1 over something, or 1 over the square root of something. Those are the 3 places where domain is going to break down and have problems. Now, the good news is if there's anything else, literally anything else whatsoever, then you can just put for the domain, you can just put all real numbers. So that would be negative infinity to positive infinity. So if you don't see, so if there's no square root, if there's no 1 divided by something, then your answer is automatically going to be negative infinity to positive infinity, because those are the only 2 things that can mess it up. And of course, 1 over the square root of something, that can also mess it up, but that's just the last 2 combined. So if you don't see any square roots, you don't see 1 over, guess what? Negative infinity, positive infinity, all the way. You just take that straight to the bank. You don't got to worry about it. So with that in mind, let's go back to the lesson. And now we're going to look at range. So range we can find graphically, or we could find it algebraically. So we already talked about how to find it graphically. You know, you just look at the chart and then you see, well, how high does it go? How low does it go? And then we check those. But the other way to do it is to do it using a bit of algebra. So what we're going to do is, we are going to essentially do what's called an inverse function. So real fast. So if we say that y equals, x plus 3, then what that means is that, so this is the input and this is the output. So what we're going to do is we are going to swap these two. So we're going to swap x and y. So we're going to go down here, and now we're going to say x equals y plus 3. And we're going to say, okay, so now that these are swapped, are there any y values that I can't plug in? So in this case, I can plug in any y value that I want, and I'll still get an x value, right? So if that's the case, then, any y value goes. But sometimes it's not immediately clear if that's possible. So typically what you want to do, after you've, made sure you've swapped your x and y, is you want to take this, so x equals y plus 3, and you want to solve for y. So you want to do minus 3, so x minus 3 equals y. And you want to ask yourself, what would the domain of this be? So the domain of the inverted function, so when you switch x and y, you check the domain of that one, and whatever the domain of that one is, that is going to be our range. So that might sound a bit, that probably sounds more complicated than it is. So let's do one that we've already looked at. Let's do y equal, let's get a brush that works. So let's say we got y equals x squared. So we looked at the chart before, and we know that this guy is 0 or bigger. So the lowest value we can get is 0. We can go up to infinity. So the range ought to be 0 to infinity. The lowest y value to the highest y value. So let's see what happens when we switch our x's and y's. What does that have? What does that do? So we'd have x equals y squared. Okay, so that's not so bad, but I want to get y by itself. So the opposite of a square is a square root, so I'm going to square root both sides. So the square root of x equals the square root of y squared. In this case, the square and the square root are going to cancel. So that means that y equals the square root of x. So the domain of this guy, x needs to be greater than or equal to 0. So, up there, I didn't write or equal to 0 because we do have 0 on this chart. That's a filled in dot there, so we should have 0. Spoiler alert. So over here, 0 is the lowest number we can have, but we can have that number. So you can have that number, and you can have anything bigger than that number. So once you do that, instead of labeling it the domain, since we switched x and y, we label this the range. Bada boom, bada bing. There you go. Now we have the range. And we're able to tell other people what the range is. Oh, so you got y equals x squared. Well, the range of that guy, you're going to get from 0 to infinity. Because when you square a number, it's always positive. So the lowest you can get is 0. The highest you can get is the highest number that you can think of. And so that is how we find range algebraically. So moving back, so we know how to find range via algebra, and that is going to be the end of that lesson. Sorry, I went back a bit because the video started playing. It plays in my ear. So that is going to be the end of that lesson. Whenever we actually go to do the synchronous hours, I am going to have some functions that we're going to look at the domain and range of. So this one's going to take a lot longer in person because we're going to play around with a lot more examples that I can change on the fly while we're in a video call. But in the meantime, that is the end of this video. I would recommend that you check out desmos.com, D-E-S. Actually, you know what? I'll put it on the board. Hold on one sec. I will put it on the board. So that is... So let me clean the board real quick. Boop, 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 boop. Okay, so that is going to be desmos.com. It is a lovely online graphing calculator. That will help you kind of visualize it a bit more if you don't have a graphing calculator, or if you just don't want to have to plot everything by hand. Desmos.com is an excellent website with an excellent graphing calculator that I would highly recommend, because it also allows you to fiddle around with the functions as you're getting stuff set up. So Desmos.com, can't recommend it enough. It will make this a lot easier when you're going to do it. Okay, and so with that, I'm going to let you guys go. I will see you guys in the next lesson. Bye-bye.